All right. Good morning, good evening, good afternoon, boys and girls. It's time to do Packet Tracer Lab Quality of Service, QoS. So let's talk about this lab. We are going to work on some critical applications, mainly related to voice and video, receive the bandwidth and the low latency that they need, even when networks are congested. In this, students will configure and test QoS policies using Cisco Packet Tracer. So let's go over to the objectives of this lab. What do we have for today? Classify traffic into different categories: voice, HTTP, ICMP. Apply QoS policy using class maps and policy maps. Verify QoS operation by generating traffic and checking markings. Understand how QoS is used in enterprise networks and CCNA exam scenarios. So that's a little bit of some of the topics that we will be covering today. Let's take a look at the topology. In this topology, we have two routers, router 1, then we have router 2. This is our 2, and this is our 1. We have a multi-layer switch. It's about a total of two multi-layer switches. There is two PCs in total, two PCs, and two servers. That's what we have about it. We're going to work along with OSPF configuration, quality of service. Most of the configuration is already pre-built. We are just going to add the quality of service specifically for these routers. What else do we have? Actually, is router 0 and router 1 that we have over here. So let me just erase the information for a moment, and let's just add it again. Let's just add it one more time. We have R1, R0, and R1. That's pretty much everything that we have for today's lesson. So let's start with the configuration. Let me erase the board and let's go ahead and open the Packet Tracer Lab. We're going to work with the initial Packet Tracer first, and then you will have both. You will have the initial Packet Tracer and the completed scenario. It's pretty much the same lab, but we are going to start adding all the quality of service configuration to both routers, R0 and R1. And that's pretty much what we are going to do. Later on, we're going to do some show commands and simulations with this topology. So let me just share the diagram with you. Here's we have the configuration. You will have this specific lab. We move from simulation to real time. So it finally finish all the traffic conversions. And let's start with the files with the configuration that we need to start adding to these devices. So we're just going to copy and paste and then explain what is being added in each of the devices. Okay, so let's start with R0. I'm just going to go ahead and copy all the configuration for R0. I need to validate in case there are spaces missing or something like that. So let's go to the CLI and see if we can just copy and paste the configuration. There is a config T. Looks like some of the configuration might be pre-built, but I'm just going to copy and paste it there. Before I do that, let's name it. Let's do hostname R0. So now we have the R0. And then we're just going to copy the whole configuration here. Let me just copy and paste it there. Ent and WR, and that's it. Now, what are we configuring specifically for R0 in this case? Okay. So first we're adding the class map for voice, the RTP configuration, HTTP, another class match, and then we have the HTTP configuration. Maybe I can move this around so you can see better. Yeah, great. Okay, then we have the class map for ICMP and the match protocol for the ICMP. Okay, and then we have the marking policy It's actually written in Spanish, so we may have to change it to English. Yeah, let me work on that. But this is actually the marking, so let me see if I can change that. Give me just a moment. Hmm, marking here. Hmm, so marking. Okay, I did the adjustments. So the first thing I'm going to do is just copy and paste the whole configuration again, just to cover our backs. I do a config T, and then I paste it there, and there you go. Next thing I do, same thing with R1. So let me just copy this. Let's go to R1. Yeah, we already configured R0 successfully. So let me just do an enable config T. Let me just paste it there. Let's do an end and config T again. So we can do the host name. In this case is R1. Okay, WR, save the whole configuration. And that's pretty much what we needed there. Now, let's go ahead and analyze the information that we have. In the R0, we have some traffic prioritized mainly related to voice, HTTP, and ICMP. Then we have the policy marking, the class for voice, the priority, and then we have the class for HTTP and the class for ICMP. And then we are applying these specifically to some interfaces. So that traffic is sent through those interfaces. In this case, serial 010. If you go to the diagram, you will be able to see serial 010 here. And let's take a look at router 1 to see what do we have in the configuration there. And finally, at the end, we have some clock rate information, some service policy marking output information, and the OSPF at the end. Let's see, router 1 is pretty much the same. We have a voice, HTTP, and ICMP. We have the match for specific protocols, adding priority to those services of our voice, HTTP, and ICMP. We have the remarking, we have the precedence, and the policy map for the class for voice, for HTTP and ICMP. There's a precedence of 5, 3, and 0. So we can add different types of priority, those kind of traffics. At the end, serial 020, we are adding a service policy input, remarking, and then OSPF. That's pretty much everything that we have prepared for today's lab. Now, let's take a look just to validate if the configuration is actually displaying there. Let's take a look and see if there is something wrong that we might need. Okay, so this one in serial 020, I'm going to see if I can remove it and then add the version in English because it's taking the version in Spanish. So let me see if I can just fix it. Interface serial 020, and then we can do a no command and paste it there. And then the same command, here we're going to fix this as remarking, just to cover our backs. If it is not that way, if it is already that way, we should be all good. Do WR, let's do a show run there and see if it is changed, hopefully. And there you have it. Let's do the same with router 0. Let's do a show run there to validate the information. So show, and then running config, and let's take a look. Now, you can see it's actually written in Spanish, so we just have to remove this one in the interface and change it to English. So let's do that. Config T, interface serial 0 10, no, and then we paste the command, and then we paste the command again, we do a Control A, we validate, everything is good, all right? Okay, and then we are going to change this for marking. Now, I want to validate something else. Let's do a show run again to see if there is something else that we're still missing there. We have the marking and remarking. Okay, yes, the policy map. We might need to delete this policy map um, because it is actually repeated. So let's just go ahead and do a copy and let's do a config T. Let's do a no and let's just paste it there. Let's do an end and a show run. Okay, let's see if now we have the English version only. There you go. There you go. There is the bandwidth. There is the AF31. And those are basically protocols for the different kinds of traffic. We are working along with a class for HTTP, a class for voice, and a class for ICMP traffic. What else? We are adding different kind of priorities and protocols. Let's go ahead and do a do WR to save the configuration, and let's take a look at this router one once again with a show run command. Now we're probably having the same. This is actually the policy that we need to delete in case you have that one in Spanish. Let's do the config T and let's do a no. And let me just paste it there. Let's do a do show run. And let's validate that we now have only the remarking version, the English version. Yeah, everything looks perfect. Great. So let's do WR just to cover our back, and that's it. We have finished the whole configuration. I'm going to save this topology on the Cisco Bucket Tracer Lab. And now the most important and essential part. We need to do show commands so we can validate all the quality of service that we have been configuring on. So let's go ahead and work on that. Let me just work and show you some of the validation and confirmation commands that we need to take a look at. Let's start working with router 0 first. Okay, first thing we do is show IP OSPF neighbors, and you can see the neighbor that we currently have. Second validation command will be show class map. There you go. You can see actually the different class maps for voice, HTTP, and ICMP that we have successfully configured, and the protocols that we have for voice. We have RTP. For HTTP, we have the same one. And for ICMP, we also have the same one, ACMP. Okay, let's do the next one, and it will be show policy map interface and enter. And there you have it. We have marking, we have the output information. We are working along with serial 10010. What else? Okay, you can see the match information here for the different kind of traffic. We have voice, we have HTTP, we have also the class in this case, and you can see all the information there. Now, let's see if we can do some testing there, maybe like send some packets along, and hopefully they will work eventually. Before we run that command once again, and hopefully what we need is to do some matching. Let's run that command again with the arrow, up arrow, and let's click in enter and see if we have some ICMP matching information there. Let's take a look. And what do we have? 5 packets. We have a total of 5 packets that are marked. Probably when we were doing some ping tests with those envelopes. And let's see, we have some of the matches there. It's actually 26 packets in total. I don't see any matches per se, but the filters and the rules are successfully applied, and we are prioritizing traffic for those specific um, kind of ICMP protocol per se. This is a bandwidth of 25, and that's pretty much what we have there. I'm wondering if there is a way to test the HTTP So I'm just going to test it. I don't know if we have the option to maybe try to reach one of the servers. Let's try to reach the 10.1.3.150 and see if we have the option. There you go. It's actually an academy, a Spanish academy. Okay, what else do we need to do? We're reaching the server successfully. We have to do some testing there. Let's see if we can test to reach the other server, the DNS server. It's actually 10.1.3.100. Okay, there you go, Cisco Packet Tracer. This is the DNS server. Let's take a look at that command that we were working along before and see if we have more information. There is a total of 10 packets. Um, I don't see any voice per se, but I need to see if there is anything related to HTTP. There is actually 10 packets in total related to HTTP. With the space, you can actually see all the information. You can see the ICMP traffic that is being prioritized, and you can see the HTTP traffic that is also being prioritized with the DSCP protocol. What are we missing there? I think we're pretty much done with this. Okay, let's take a look at another command to look at information, and that will be, we have done the map. Have we done the show IP policy? Show policy dash map? Yeah, there it is. We did the class map, and we have the policy dash map interface. That's pretty much all the main important commands. We are going to do show access list. Looks like there is not an access list configured for these devices. Show IP traffic. Let's see, we have information here. What are we missing, boys and girls? Show IP traffic. No, this one doesn't work because we might have to work with real equipment, and looks like Cisco Packet Tracer doesn't support those. But the access list actually is supported. It's just that we hadn't configured any access list. Let's validate the show MLS QoS interface. That one isn't supported either. So those are some commands that we can work with GNS3 and other topologies in more advanced scenarios. But for now, we have pretty much covered everything that we have for this topology. Let's validate something else with the commands that we were working on before, like, for example, the show policy. Let's validate that we have a precedence value of 5, 3, and 0. Let's see if we can see that information there. No, we don't see it. Let me remember the other command. Show policy map interface. Let's see if we have the precedence there. I don't see the precedence value. I'm trying to validate if we have those there. Okay, what was the other command? Show class map. Let's see if we can see it with the show class map. Show class map. No, I don't see the precedence value per se on those informations and commands. But there is actually another way. If we do a show run, let's see if we can find the precedence value that we have configured there. Let's see. Where did we add it? That's a big question. Precedence value. Did we configure the precedence value there? I don't see. Yeah, it's actually in the policy map remarking. So let's go to router one and let's do a show run there. And a show run. Let's see if we can see it there. Yeah, there is. It's in the marking for the router one. There is a set precedence of 5 for voice, a set precedence of 3 for HTTP, and a 0 precedence for ICMP. Let's validate the same commands that we have for class of service in the other router. We were doing these commands in router 0. Now let's work along with router 1. And you can see actually there is so much IP information regarding those protocols and services. Let's do a show policy map here. And you can see actually the precedence values of 5 for voice, 3 for HTTP, and 0 for ICMP. Let's do with the interface command at the end. interface. And there you see it. Amazing. You can see the different protocols for the different services. And there is actually some packets and bytes. There is the packet mark. There is a 10 here, a 5 over there, and this is a 0 over here. Nice. Now, there is something else that we're missing before we close for today's lesson and lab. Mm, let's go ahead and move to simulation mode. And let's start with sending sub packets with the simulation modes. I want to analyze some of these packets. Let's see if I can find more information regarding these packets. The output PDU. And what I want to find, and we're trying to get, is information related to quality of service in those packages. So that's what I'm looking for. I don't see it yet, but I'm just going to validate. Let me go ahead and pause the recording so I can validate which of these packets we need to analyze. Preamble. Yes. TTP. Information for data. The apps of service. Okay. That is is a router 0 above packets. And DSCP. Okay, router 0 in both packets and DSCP. Okay. Okay, so it's showing a little bit because this is a simulation and we don't have that much information per se. But if we go in the simulation and we analyze router 0, let's look for router 0 over here. Let me just go back there. Router 0 will show us some of the information. Let's look it up. Let's double click on it and let's go to inbound. And you can see the DSC key is 0x00, and that is what we are simulating. Some of the priority and classes that we have previously configured, and that's what we were trying to find. So far, we were having a little bit of difficulty to find that information. So if you analyze the input PDU details, you can see DSCP. Let's see if in the output the same information pretty much. Yeah, it's pretty much the same information that we have there. For DSCP, for output and input, you can see here 0x00. This is the source IP address and the destination IP address. If you guys remember, this is related to multicast. We are sending to all different devices that information and traffic. And pretty much what we configure in this lab, let's just stop the simulation for now. Let's move to real time. If we analyze, like for example, router 1, you can see that we were doing priority, adding priority for voice, for HTTP, and for ICMP services per se. So I hope that you have liked this lesson, this lab. We have been doing some commands, adding some information, mainly related to priority of traffic, and also adding some important commands for quality of service. Becoming familiar with this in a production environment or a similar simulated packet tracer environment. I hope that you have an amazing day, an amazing week. Remember, practice makes perfect, and I'll see you at the top of success. Until the next lesson, and goodbye.